The next topic will be test case specification, and this presentation will be held by two different speakers, which I warmly welcome now. The first one is Dr. Ludwig Friedmann. He is at BMW as well, and there he is solution architect for simulation of autonomous driving. In the Z-level project, he is active within the domain simulation, architecture, and interfaces. And furthermore, he does testing and modeling of physical sensor models and materials. And he is accompanied today by Dr. Markus Deppe from the company of dSPACE. There he is manager for engineering services and pre-development. In the Z-level project, Markus coordinates the dSPACE activities, for example, simulation use case number 2 and 3, scenario and map generation, scenario variation, testing, and furthermore. So a warm welcome to both of you, and now we are curious to see your presentation about test case specification.
Thanks for the introduction, Verena. I hope you can see our presentation now.
Yes, we can. We can.
Perfect. So hello again, everybody. My name is Ludwig Friedmann from BMW. Together with my colleague from dSPACE, Markus Deppe, today I'd like to introduce you to our demonstrator on test case specification. Test case specification. Why is this an important topic in the context of Z-level? Well, in the automotive industry, development and validation are based on requirement-based testing. Before a product, such as a car or a component, is developed, a specification is created. Fulfillment of the specification marks essential milestones in the development and is basis for final validation. Requirements from the specification are managed in a dedicated requirements management software. From the requirements, test series, also named test campaigns, are derived and deployed to test instances by a test management software. Test instances then execute the tests and report test results back to the test management software. Finally, the test management software accumulates test results and reflects them back to the requirements management software, so that in the end, this process enables traceability between the requirements that were defined in the specifications and test results. And ultimately, it enables reviews on the achievement of development objectives. Now, in the context of Z-level, scenario-based testing is the most relevant test method to challenge automated driving functions. Let's see how this can be integrated with requirements-based testing. We already introduced you to the concept that a test management software distributes test campaigns to test instances to run test cases. This approach obviously requires some kind of test software running on each test instance. Now, for scenario-based testing, scenarios can be added as test artifacts. They are usually executed by an environment simulator, and optionally, parameter variation may be implemented to enrich tests and the scenarios. As we can see, in the ideal case, test cases should both integrate with requirements-based testing on the one hand and scenario-based testing on the other. This would allow modularity and exchangeability of test cases and scenarios. Now, what's our proposal to reach this goal of modularity and exchangeability? Well, it is based on clustering software architecture and corresponding file formats in a modular fashion, while the test case acts as an abstraction layer between requirements and test instance specific implementation. We've already seen test campaigns describing distribution of test cases to test instances. Now, we are introducing generic test cases that add sequential, human-readable test steps defining a test run. Those test cases use generic keywords to reference test instance specific implementations. Let's take the topmost example, establishment of operational readiness. In the case of a SIL, this could be translated to launching some applications, while as for a HIL, this could involve starting up real hardware. Sorry. Finally, for scenario-based testing, scenarios are complemented as script of the virtual world with the character of a bird view. A macroscopic view on the virtual world, not incorporating any vehicle internal states or evaluators. This concept enables modularity and reusability of test cases and scenarios. The same scenario can be used in different test cases. Tests are agnostic to the architecture of individual test instances. Testers do not need to possess any programming skills. And ultimately, tests and scenarios can be exchanged throughout the industry. You're probably wondering how the concept of human-readable generic test steps works with an arbitrary test environment. Key is the use of keywords, such as initialization or specific evaluation requests. As an example, let's have a look at the initialization step in this test case. Enriched by some parameters, the keyword in this XML-based test case is translated to a script file reference. initScript.py would be named consistently on different test instances, but for each test instance, it has a specific content, e.g. specific file paths and/or parameters. Using this simple principle, the same test can be used consistently throughout test instances and companies. In order to evaluate the presented concepts, during the last month, we implemented a series of proofs of concepts. Following an agile approach, we started off small with a simple application reading generic XML test cases and writing corresponding results to disk. This arbitrary test software translated keywords into specific implementations represented by Python scripts. The scripts, again, interfaced an arbitrary test environment, comprising an environment simulator, a mocked system under test, and a network interface to evaluate simulation results. In the course of development, the proofs of concept we created were extended in multiple directions. For example, concerning evaluation and accumulation, we found out that precise definition was mandatory and that accumulation requires metrics as well. Concerning synchronization and timing, we realized that while we were running the test software as fast as possible at first place, synchronization between test environment and test software is relevant for more sophisticated tasks. And finally, concerning KPIs and metrics, we realized that KPIs have to precisely reflect test metrics and vice versa in order to ensure consistency and traceability. Now, so much for the theory. To give you some further insight, I'd like to hand over to my colleague from dSPACE, Markus Deppe. In a brief demo, he will introduce you to the implementation of the concept using dSPACE industrial-grade software. Markus?
Yes, so I'm going to present the implementation of the proof of concept for this tool, independent test case specification. In this demo, we are testing a simple ACC scenario on a straight road. The demo is split into the three parts: test preparation, test execution, and test evaluation, as indicated at the top. Starting point are the requirements which we then use to derive a simple test. Our concept can combine requirements-based and scenario-based testing in a keyword-driven approach. Thus, a scenario description is part of the requirements. In this case, we have a long straight road with an ACC vehicle approaching a slower vehicle. In this situation, the ACC vehicle needs to brake and adjust speed and distance. As a main requirement, it is defined that the minimum distance between the vehicle never falls below 60 meters. Our approach for the proof of concept is to implement the system under test, which is the ACC-equipped vehicle, and also the environment, which is the simulation of the road and the vehicle in front by means of an industrial solution. We have chosen dSPACE automotive simulation models, short ASM, together with ModelDesk and the VEOS simulator. By this, we are able to focus on the main task, prototyping the generic test case specification. First step in our test preparation phase was to edit the road and the scenario in dSPACE ModelDesk according to the presented requirements. Of course, it's also possible to reuse existing requirements or import from OpenDrive or OpenScenario. The system under test is represented by a dSPACE ASM model, which is an open Simulink model consisting of a complex vehicle dynamics model, powertrain, an ideal ACC sensor, and an ACC controller. By parameterization and modifications in Simulink, many different realistic vehicles can be set up, including full electric vehicles, hybrid electric vehicles, etc. The environment model consists of the environment block of the ASM and contains the scenario engine, the road simulation, the surrounding traffic, in this case, the slower vehicle in front. And we implemented one extension. This is an interface to periodically send OSI ground truth messages via TCP to the evaluation script of the test implementation. Later in the demo, we see how this message is used to calculate the distance between the two vehicles. For every part of the ASM model, parameters exist to adapt the model to concrete vehicle specifications. All in all, several thousand parameters are offered and can be configured with dSPACE ModelDesk. For every area of the model, a specific parameter configuration page is available. For the proof of concept, we have implemented 6 test steps. 2 example steps will be explained in greater detail. Example 1 is the runtime test evaluation step to continuously calculate the distance between the vehicles with the OSI ground truth message, and example 2 is the post-run test evaluation, taking the minimum distance from example 1 and comparing it to the threshold of 60 meters for test verdict. Each test step is implemented as a tuple of an XML step and a script reference in XML. The XML code is implementation independent and reusable for different test platforms. Here, the XML code defines a parameter list with object IDs interpreted as OSI identifiers in the script. The script periodically receives the OSI ground truth message from the environment simulation and calculates the Cartesian distance between the two vehicles. The distance vector is passed on to an internal storage of the test software for the next test step. So let's go to example 2. This is the post-runtime evaluation. And this step will call a script function called accumulate results. And now we can see how a test engineer translates the requirements to keep at least 60 meter distance to the test case specification. To do so, a test step can be configured by parameters. And during runtime, these parameter values will be passed on to the step script. In the proof of concept, we implemented a convention for this interface between the XML code and the according function call into the script. Here, the threshold of 60 meters, the greater than comparator, and the minimum metric are programmed in the XML editor. The key idea for this kind of XML specification is to be related to the requirements, but to keep out all details about the technical implementation of the test itself. The XML code is agnostic against the test technique, the chosen script language, or the format of the recorded data. The step script takes the distance vector from the previous step, determines the minimum distance, and checks against the threshold. This script obviously offers a certain flexibility, and just so you can reconfigure the test step without touching the script code. Now we have all artifacts for the test in place. We have the arbitrary test environment, which can be any tool change. Here it's dSPACE solution. The generic XML test specification is the focus of this proof of concept. Today we have many different proprietary test case specifications, but none of them are exchange format. So our generic test case specification is the test software and test environment agnostic and aims at being highly exchangeable. The test scripts are specific to the test environment since they also implement the interfaces to the system under test and the environment simulation. Sorry. Now we come to the test execution phase. And here on the right-hand side, we see an Explorer window containing all the files for the test. The action folder contains the step scripts and artifacts. Testing software POC.py is a prototypical test software. Test cases acc.xml is the test case specification. And the batch file is required to run the simulation. And when looking at the content, it's just one line which starts a Python interpreter on the test software and passing on the XML specification to the test software. Now I'll start this batch file to run the demo. And now we are in the initialization phase where the animation tool and the simulation platform VEOS are started and are configured with all artifacts for the test. Afterwards, the two test steps for runtime and post-runtime evaluation are running in the execution phase. In the console output is the current OSI ground truth timestamp. At around 10 seconds, the vehicle in front becomes visible in the upper right corner. The ACC vehicle approaches, brakes, and keeps a constant distance. At simulation time step 20 seconds, the simulation ends, and then we are in the tear down phase where the results are stored and the simulation platform is shut down. This brings us to the next phase, which is the test evaluation. And for this, we have implemented a simple XML schema in our proof of concept to store the test result. And in this test result, we have things like the name or unique ID to identify the result. We have information about the start time and duration of the test, and of course the test result itself, which can be passed, failed, blocked, crashed, or exception, things like that. And in our case, obviously the test case is passed. And this result is then passed on to the test management software, which stores every test result. And the task of this test management software is to do the test planning and the aggregation and visualization of results applied to multiple tests, a test campaign or multiple test campaigns. The proof of concept is available product internally now, but we are considering making it open source to involve more interested parties in our test specification topic. And I thank you for your attention. And now I'll hand over to Ludwig Friedmann again.
Ludwig, we can't hear you.
Sorry, I didn't know
Now
I was muted.
Yep.
Now we go.
Okay. Thank you, Markus. As Markus stated, this is not something that is meant to be kept behind closed doors. Currently, we're looking for a way to open source this development. Moreover, the presented concepts are pursued in the context of standardization at the ASAM test study group. So what's left to say is stay tuned. Thanks for your patience, and we'd be happy to answer your questions.
Thank you, both of you, Ludwig and Markus, for your presentation. Yeah, and it is again Jochen who will read through the questions and address them to you. Jochen.
Yeah.
Let's start.
Thank you for this very interesting speech. You mentioned at your last sentence the activities on the ASAM and open scenario. So I want to ask, maybe you can make it a little bit more clear what is missing in open scenario so far that you added in the test case description. And the second part of this question, how will you or do you already contribute all your results into the ASAM activities?
Right. So this is these are basically two different questions. So first of all, what we presented here is a modular concept where the content of a test case description is explicitly excluded from scenarios. In the ASAM Open Scenario 2.0 project, there were ongoing discussions if parts of the test could be part of the scenario. But this point actually led to the development we've seen before and also to the foundation of the ASAM test study group. Goal of this group is to identify what requirements from scenario-based testing exist on requirement-based testings and how to properly integrate scenario-based testing. As said in the beginning, there were some ideas on how to integrate some test aspects in a scenario. Nevertheless, what would have been the result is an isolated solution that would not be compatible with what's present right now at automotive development and validation. So this was the initial reason to put the focus on this topic and start some research at ASAM if a test specification or standardization on a test specification was required, and of course, how scenario-based testing could be integrated. To the second part of your question, Markus and me were both participants in the ASAM test study group. We are trying to convey these ideas to ASAM. Nevertheless, standardization is out of scope for, or the capacity that would be required for standardization would exceed the capacity we have in set level. So we see this development we have created within the proofs of concept as kind of a starting point, as discussion base. We will happily transport to the ASAM discussions, but then definitely a larger group and also more capacity is needed to evolve this topic to something that could call itself a standard.
Okay, thank you, Ludwig. Maybe a remark from my side to the audience. I think this is quite a nice example how we work together with the standardization consortia. So we are developing new ideas, improvements of the existing standards, and then bring it into the activities as just any other member of these projects, like in ASAM or in Modelica Association. Okay, so next question from the audience. So there is one question from your colleague in BMW. He remembers that there are some test case standard formats from the telco domain. Mm-hmm. So did you use this as an input to your work?
Not yet, obviously. So we would be really interested to have insights in this in other domains as well. Probably they are helpful in order to further evolve and further develop this test case specification at ASAM. Right now here at set level, it was just a brainstorming that brought us to this point, how we can abstract the test environment from requirements that led to the creation of this test specification concept.
Okay, so there is a question regarding these XML file formats you mentioned several times. So is this what you mean by this human readable format in your proof of concept?
Yeah, this is what, of course, with a different view on the XML file. So XML is sometimes hard to read, but the content of an XML file could be visualized in different ways. And let's say for a tester, I would rather visualize the keywords that are part of an XML tag that describes a test steps, while for the programmer, the specific content of this tag may be more relevant. So the idea is to have a human readable test description, of course, with some preparation and some improved visualization of the XML. But on the same side, a test case description that is precise enough to reproduce the content of the test throughout the industry in different companies, throughout different test instances. Agnostic to the actual test environments, as we've stated, using scripts and keywords. But in the end, the XML format you've seen is our first proposal for a test case specification.
Okay, so there is another very interesting question. You came from the requirement-based testing to the scenario-based testing. So there is a question, do you have any approach to get maybe automatically from the requirement to the scenario and maybe vice versa, do the evaluation of the results backwards in the same way automatically somehow?
Well, so we're at the, so what I've described before, the tool chain in the automotive industry, this is something that is already present. This is not as Markus also said, this is not standardized, but this is present at many OEMs. A requirements management software and the derivation of test campaigns from these requirements in order to run large numbers of test runs on test instances and then reflect those results back in order to do the validation of those requirements. So this is something that has been in place for years now. Of course, and this is something we pointed out on the slide with the architecture of the proof of concept. Requirements are sometimes formulated rather vague. So, for example, so we named it KPIs because that's the term that is used in the Z-level project. A key performance indicator could, for example, state or request robust and precise behavior and reproducible behavior of an automated driving function throughout 100,000 kilometers. If you want to derive tests from that, you will very soon come to the point where you see that there's information missing. And this is the key question here. If a requirement is defined precise enough so that I can derive a reproducible and precise test specification from that, there's no problem at all. If I'm talking about interpretation of requirements and an automated fashion to do that, I would ask myself in first place if I wanted to do that, because this, at least for me, it smells like interpretation. And this is probably something we do not want in street certification or validation of automated driving functions. So to answer the question, what we found out during the proofs of concept is that the very precise definition of metrics used in test cases should reflect what's stated in the requirement and vice versa. The person writing the requirement has to be very clear what he wants to be answered in the end, so that he can build on the results from, or that he can interpret the test result properly.
Okay, thank you very much. There is another question or additional question regarding this standards open scenario. So do you think that the coming open scenario 2.0 or MSDL could fill the gap or between scenario description and test case specification?
Okay, it would be easier to know what gap exactly is meant here. Personally, I feel that evaluation and vehicle internal states should be kept out of scenarios in order to make scenarios exchangeable, to use scenarios over different tests, over different OEMs. And as a regulator, I would even want that. Yeah, I would have this as a requirement so that I created a scenario only once, created a test once, and then ask potential customers of this requirement or certification clients that they use the same test and that they provide a result for exactly this test. And so I would keep this this abstraction layer in one place and have the scenario as a test artifact so that it fits into requirement-based testing, but I would not try to have either abstraction or evaluation part-wise in the scenario, because this may make understanding what happened in the test slightly more difficult, and it makes it also, at least in my understanding, less maintainable than if the abstraction and the interface between generic requirement and specific test environment more transparent.
Okay, so maybe 2 questions to Markus. The test case description you presented here, is this limited to a certain test technique, for example, requirement-based testing or interface testing or fault injection, or to the test goal like SIL, hill, or a vehicle in the loop?
Yeah, thanks for the question. So definitely this is not the case. So it's totally generic, and I think in the slides from Ludwig, it can be seen that it is a very this step-based approach is really running without scenarios. It's suitable for fault injection testing, for interface testing, and the basic idea is to make it exchangeable across the different test instances, from software in the loop to hardware in the loop, or vehicle testing, or whatever. So its design is really strict in a way that it can be used throughout the complete homologation process you have for your vehicle, if you'd like to do so.
Okay, this is fine for the test goals or the testing platform. What is with the different stages of the development phase? So is it also usable throughout the complete V?
Yeah, definitely. So there is absolutely no limitation in this area. So this is for development, internal testing, for homologation testing. It's usable in the same way, and as we said, it's intended to be exchangeable across departments, across companies, or exchangeable between authorities and car manufacturers. And this is the most important topic of this, or design goal of this test specification. And that's also one reason why it is totally important that it is not tied to a scenario description language, but because in many homologation tests, scenarios do not play a major role.
Okay, so last question from my side is, we heard in the morning something about the credible simulation process. How is the linkage between this and your test case description?
Yeah, the credible simulation process is more or less a kind of documentation schema to fulfill the traceability requirements, and it's very compliant to common ISO or dSPACE requirements you have for your development. So it's pretty generic, pretty flexible, and testing as an engineering task is inside this credible simulation process. But the credible simulation process does not explain in detail how this testing, or by which tooling or which formats is supposed to happen. So it's absolutely compatible, I would say.
Okay, thank you. I think we are done with the Q&A time. So back to Verena.
A lot of questions. Thank you, all of you, Ludwig, Markus, and Jochen, of course, as well.